Hi guys, welcome to another week of Math as an Adventure. This week officially ends on May the 4th. So guess what our theme is this week? I am Space Princess. Just for, legal rights issues. All right, so what we're going to do is we're actually moving on to another chapter this week. We are going on to chapter 9, which means we are going to be doing things with radicals. So we're still going to use it with this quadratic stuff. Like I said back in school, we are going to be using this quadratic stuff for the rest of the semester. So we are going to be using radicals to help with these quadratics. So what we're going to do is we're going to start with some radicals information and work on simplifying radicals and all that kind of stuff. You've been through it a little bit before, I think, in 8th grade, but we're going to go through some of it again. So let me go ahead and get what we're going to work on up here. All right, so what we're going to do, and depending on where it shows up for you, my face might be right over some of these words. So what we have is our 9.1. That's the first section of this chapter. And we are going to work with our radicals. And we need to know some of our vocabulary words, which would be the radicand. That's going to come up in the homework, is this radicand. And we need to make sure that we know what that is. So radicand, let me grab my pen real quick. The radicand is the bit that's under the radical sign. So this square root sign down over here, this square root sign, the radicand is the bit that's under it. So this, that is our radicand. So what we're going to be doing for the first bit of this is we're going to be simplifying these radicals, which means we need to make sure that there's no perfect square factors. So we did factors when we were doing our solving quadratics with factoring stuff. If you think about that T that we made where we listed our factors, that's what we're going to be looking at, except we're only going to look at perfect squares. Okay, so the radicand can't have any perfect squares still inside it. It cannot have any fractions, and it can't have any radicals in the denominator. We're not going to do a whole lot with the denominator stuff. We're going to have a little bit, but not a whole lot. So if you are curious about what to do more with the radicals and the denominators, check out the textbook. They have a whole lot more about that. We're just not going to go through that with our shortened e-learning situation. All right, so let's go on to our next page and we will go through some of this. So what we're going to be doing in the homework is we're going to be looking at this product property. So this is a way of getting rid of those square roots inside these radicands. So what we're going to do is we're going to look at that number inside that radicand. So like on this first one, we're going to look at this 108. And what we're going to do is we're going to look at the factors of it. So we can do a whole factor list and you go 1, 2, 3, 4, just like we did when we were doing our factoring. Let's see, eraser. When we did our factoring with our X-frame and our quadratics. Or, since we only really care about perfect squares, in this case, what we can do is look and see what's the biggest perfect square that fits in evenly. So I'm just going to list my perfect squares because that's all I really care about. So we can do 1, we can do 4, we can do 9, we can do 16, 25, 36, and so on and so forth, and all that jazz. All right, so you can just start with a list of your perfect squares because that's all we really care about. All right, so then what we're going to do is we're going to grab our calculators or grab your phone, and we're going to see if these have nice, tidy factors, no decimals. So, well, clearly, 1's going to fit in because 1 times 108 is 108. So let's see if 108 is divisible by 4. It is. It gives us a 27. Is 108 divided by 9? It is. And it gives us a 12. So we've got a lot of perfect squares inside here. We want to find the biggest one that fits. All right, so let's see if 16. This one comes up as a decimal. You get 6.75. So this one is not going to be a factor for sure. Let's see, 108 divided by 25. That's going to give us a decimal again, 4.32. So this one is not a factor. So let's check our 108 and the 36. That one's going to give us 3. So that one's looking pretty good. So since we still are finding things, let's check a couple more. So the next square up from 36 is going to be 49. Oh, but I switch colors. And then we'll have 64. And I bet that's, where we're going to start reaching our swap. So 108 divided by 49, that gives us a decimal. We've got 2.2. So that one's not going to count. And then 108 divided by 64, we've got 1.6. For sure, once you get past the ones or down into the 1 points, you will not have any more perfect square factors. So if you want to go through the whole list of perfect squares, that's totally fine. Once you get past that 2.0, you are not going to find any more perfect square factors. All right, so what we have here is we're now going to figure out which one is our biggest perfect square that fits in. And that's going to be this guy here. That's that 36. So what the product property says is that the square root of 108 is going to be exactly the same as if I was to split this into 2 factors. Because what 108 is really 36 times 3, right? That's what we said down here. So the square root of 108 is the same thing as the square root of 36 times 3. The product property lets us do is split this apart right here. So we're going to say the square root of 36 times the square root of 3. And that doesn't really look all that different, but what we can do now is our order of operations is a little bit different. And what we can do is take the square root of 36. What's the square root of 36? 6 times the square root of 3. Does the square root of 3 have any more perfect squares in it? Well, 1, but that doesn't change anything. So this is actually going to be our answer, and we're going to take that 6 and that square root of 3, and we're going to smash them next to each other, because 6, when we put them right next to each other, remember that means multiplication. And this is our answer here. This is our simplified version of the square root of 108, is 6 times the square root of 3. So that's doing it with just numbers, and there are a few of those on the homework. So then we can look over here at the B one, and it's still the same thing. So that's kind of going straight into this step. This is where they're already smashed together. They're already being multiplied together, and we're just going to pull them apart. So instead of having square root of 9x cubed, we're going to have the square root of 9 times x cubed. So I can split those apart. So we're going to have the square root of 9 times the square root of x cubed. So that gives us 3 square root of x cubed. The only thing is there a perfect square in there? We can do this one again. So we're going to have this 3 still over here. I can split apart this x cubed into 2 different things. X cubed can also be written as x squared times x. So we can have this be 3 square root of x squared times the square root of x. So we can still break this down a little farther. So the square root of x squared down here, that's going to be our 3 square root of x squared gives us x, and then we've got this leftover square root of x. Okay, so when you're working on the homework, be extra careful. Make sure you're using the x on the keyboard, not the x that they mean as a multiply on Big Ideas, because there have been issues that other students have commented on about things not looking correct, but not being marked correct by Big Ideas. So make sure you're using the x on the keyboard, not the x in the calculator, because it does make a difference. So be super careful when you're writing things in, when you're putting things in. If you've got any questions, please let me know. I will be here, and I will get us another video for the next example that we're going to do. All right. So since this week ends on May the 4th, we're just going to go ahead and end this with May the 4th be with you. I miss you guys. More videos coming soon.